Hey guys, take a peek. I have as my original claim the mean less than 102.8 minutes. Do you guys see how that says that in the problem? No? Let me show you. It says, test the claim that I always go to the bottom. I don't even read the whole thing. I just go to the bottom and try and find the little question mark, right? Test the claim after treatment with Zipoclean. Subjects have a mean wake time of less than 102.8 minutes. You always want to, you have these huge problems. Before you start reading all the details, just ask yourself, what are we supposed to do? So that's why I did this as my original claim. From that, you guys should be able to get me the null hypothesis and alternative hypothesis, and I'll talk about that in a moment. But for those of you that have that, the next step is to find the test statistic. Which test statistic formula am I going to use on the sideboard, the red or the black? The black. When you're trying to go after a mean, which is what you're doing in section 4, we use the t-distribution. So I'd like you to try and use that formula and come up with the correct test statistic, because that is the next step. And I'm going to walk around and make sure people are going okay on this. And anyways, I'll be back with you in just a second here. Oh, let me throw the... knowing what goes where at the start, right? You do know one thing about the null hypothesis. That always is an equality, right? If I wrote this as the original claim, I can tell you right now I'm going to have an equality. I always do for the null hypothesis. Guys, if the original claim said equals, it would be the null hypothesis. Or if it said less than or equal to or greater than or equal to, it would become the null hypothesis. But it doesn't. If it's strictly less than, what I'll do is I'll put it as the alternative hypothesis.
So it has to be equal to or less than equal to?
Yeah, it has to have equality for me to put it as the null hypothesis. That's right.
All right. So this is kind of what I was trying to figure out the other day.
Yeah.
Is how you determine what sign to put for the alternative hypothesis. Are you saying that basically, just to put it simply, if it's just a less than or just a greater than with no equal to or no equal sign,
then make it there.
It's automatically made into
Yes.
that same thing. But if it does have any type of equal,
Then you should think of that as the null hypothesis
It would be
and
the
get the
opposite.
complement
all right,
for the
thank you.
alternative.
That's very helpful.
Awesome. Awesome.
So if
Sarah, does that help? Yeah, go ahead.
so there's no equality, then saying that null hypothesis has to have equality?
Yes.
Okay.
The null hypothesis must have equality. And so you really look at the original claim, and if it has equality, I'll go null. But if it doesn't, and so that's why you've seen sometimes we've done it one way, sometimes we've done it the other. But I think you need to have it said.
So if the original claim was mu equals, then it will
Just go right to the null.
null will be equals, and then alternative will be does not equal.
That's right. That would be a two-tailed test.
And then if it was less than or equal to, the alternative will just be greater than.
Yes.
Oh my gosh, why didn't I go?
Yes.
Okay, got it.
So that's good. That's good. Okay, so we got that down, I think. And the next thing is we're supposed to use the test statistic, right? And so again, when I look at my formulas, really there's only two, right, that I need for this section. And so let's see. We're going to have T equals, this is my test statistic, right? T equals, and the formula is x bar minus mu divided by, and the standard deviation of the t distribution is s over the square root of n. You guys have seen that before a few times. But we use, okay, so why did I pick t? Let's make sure everybody understands that. Every other problem we were using z. Why did we pick t?
Because
Here's why. It's because we're talking about means this time. What were we talking about on last night's homework? The proportions, the little p, right? For that, you'll use the normal distribution, you'll use z. But for these, and that was true with confidence intervals also, remember? Confidence intervals, first we did proportions, that was z. Then we did, for confidence intervals, we wanted to do the mean, and that's when we switched to t. Okay? So, let's go ahead and fill in what we can. X bar, oh, do we have all this stuff? Let's take a look at the problem again. Yeah, you know where we're looking? Right in here is where they talk about the study. After treatment with zopiclone, the 16 subjects had a mean wake time of 98.9 minutes. That's X bar. Right? So let's throw that in. 98.9 goes there. And then we have a 42.3 is in the denominator, divided by, let me show you so you can see what I'm writing. The square root of what? 16. That's kind of nice. What I didn't write yet is what you're supposed to do here. Minus what? Yes. So I want to make sure everyone understood that. The formula says minus mu. Remember that we're hypothesizing that mu is 102.8. That's my hypothesis. I'm trying to test, is that true or not? Right. I'm saying maybe the mean's less than 102.8. Might be, because t is going to be negative, right? I don't know what it equals, but I could see, since I'm doing 98.9 minus 102, I could see it's going to be negative, right? Let's see what it equals. Let's get that calculator back out and type it in and see what we get. So 98.9 minus 102.8 in parentheses, thanks to Jared. Right? And then we want to divide by. Okay, now it's interesting. When you go to do this denominator, I suggest we put the whole denominator in parentheses. Okay? I just think that's smart. So that the calculator will know I'm doing that stuff divided by this stuff. 42.3 divided by, now, I know it's 4, right? So I'll just type 4. But normally you would put the square root of whatever it is. Does that make sense to you guys? You have your numerator in parentheses, you have your denominator in your parentheses, you'll be fine. And that should give me a negative number, and it does. It's negative 0.368. 0.368. Or 0.369 maybe, I don't know. I'll say 0.369. I'll round. Now, what I usually do next is I either compute the p-value or I compute the critical value, right? How does it work then? Let's draw a picture. This is the first time we've done a picture for the t-distribution in this chapter, right? So what do the pictures look like? Well, guys, t-distribution looks a lot like what? The bell curve. You might remember the only difference is it's a little bit wider, right? So I'm drawing the picture twice because I want to show you there are two ways you can decide whether we're going to reject or fail to reject. For either picture, I need to know the significance level alpha. Did they give me alpha? They must have given it to me, right? Da, 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 da. I don't see it, huh? Test the claim. And does it appear effective? All right, well, maybe on the previous page directions, did they tell me? What? Well, maybe I'll just use kind of a standard value. I mean, Notice in number 12, I used a 0.5 significance level, 0.05. Yeah, Okay, well, I'll tell you what I'm going to do then. I'm going to do the p-value method. So let me show you how that works. So there's two approaches, guys. One is the p-value approach. Let me write that here. P-value approach. In the p-value approach, what you do, you guys, the mean is still 0. Oh, but the standard deviation isn't 1 anymore, right? This is the t distribution, not the standard normal distribution. But still, negative 0.369 is somewhere over here, right? So this is t equals negative 0.369. Do you guys have the picture I have? Now, when I say I'm going to compute the p-value, remember the p-value is a probability. Probability of being at least that extreme if the mean is really 102.8. Right? Because if the mean's 102.8, this is a picture of what it looks like. It's a t distribution. And so, I mean, what am I saying? Guys, how big of a sample did we take? We took a sample of 16, and we got that the sample mean was what? 98.9. I guess the question is that close enough to 102? That's what I'm really asking. If you got a sample mean of 12, you'd say, no, we're not close to 102. If you got a sample mean of 101, that wouldn't surprise anybody. Or 103, that wouldn't surprise anybody. But what about 98.9? That's what I'm asking. And so what I do is I compute this area because the area is the probability. That area is the p-value. Oh, one thing I should check. Is this one-tailed or two-tailed, this particular problem? Okay, so then my p-value is just this tail. In a two-tailed test, you would have to multiply by 2, right? So let's compute the p-value. How do I get the p-value? Well, the p-value will always equal... Well, let me ask this. How did we do it yesterday? What command did we use when we were doing the normal distribution? If we want. We did normal CDF, right? Well, let's look at what our choices are here, and you tell me. I bet if you look at the calculator's choices, you're going to know what you want. Second distribution. Where's that? There it is. I'll tell you what. The really old calculators didn't all have this. They have TCDF. That's exactly what I want. And then it's going to ask me a few things. Lower bound, is that okay for my lower bound?
Yeah.
Yeah, really low number. Upper bound? Negative 0.369. Oh, DF. Do you guys remember what that stands for? Degrees of freedom. Do you remember how to get it? It's just n minus 1, so for us it's going to be 15, right? And I'm just going to paste that in, and that'll give me the TCDF. What? I got an error. I thought it would. Go to the error. Oh, it's highlighting that. What did I do wrong, guys? I sure did. What should I use? Then I guess there may be one or two of you in here that had that happen before, right? Well, there it is. All right. So that says the p-value is 0.3586. All right. So let me write that down, right? Let me write down what we did again. We did TCDF, negative 100 to negative 0.3, and degrees of freedom was 15. And so that p-value, again, it was 0.3, lost it, 586. Okay, so what you do is you compare the p-value to what? We always compare it to alpha, the significance level. I claim this is high compared to alpha. Why do I say that? But they didn't tell me what alpha was, did they? But why do I say this is high compared to alpha?
Because alpha is always, we're usually like
0.05,
or something, right?
0.10 is the high. Have you ever seen 0.20? Maybe it's the highest I've ever seen. 0.01. You with me?
Yeah.
No one's going to take an alpha of 38%. I'm sorry, we're just not going to do that, right? So this is high. And how does that work then? What do? Do I reject the null hypothesis or do I fail to reject the null hypothesis? This is important. You've got to know. Do we reject or fail to reject? We fail to reject. If T is low, if P is low, the null must go. If P is high, we let it fly. In other words, we fail to reject the null hypothesis. Okay? Now, final conclusion. Final conclusion. How do we word the final conclusion? Well, first of all, we better look at the problem again. What was the claim? We were testing the claim that after treatment with zopiclone, subjects have a mean wake time of less than 102.8 minutes. You guys, little advice on wording. If you ever write these words down, fail to reject, here's a good way to start your final conclusion. If we say fail to reject, we will say there is not sufficient evidence. That's what you would say if you see fail to reject. Now, what if you say reject the null hypothesis? Then we might say there is sufficient evidence, or the data set supports rejection of, you know what I mean? Something like that. Fail to reject, there is not sufficient evidence. I'm pausing because I got no reason. If you're having trouble with the final wording, I want to refer you to page 391 of our book. Let me go there now. Page 391. Shows this. The original claim does not include equality and you reject H naught. The original claim does not include equality and you fail to reject. Guys, I guess I'm looking at lines 2 and 4 of this chart. They both start, there is not sufficient evidence. Because we're failed to reject. That's the point I was trying to make. All right, there is not sufficient evidence for what? Yeah. I guess if it were me, I would word it this way. It says this. Test the claim that after treatment, subjects have a mean wake time of less than 102.8 minutes. See, if we did reject the null hypothesis, let me zoom out a little bit so we can see the whole problem. If we did reject the null hypothesis, then we'd be supporting the original claim. Because the original claim is the alternative hypothesis, right? So if we had rejected that, we'd say, oh, there is sufficient evidence to support the claim. But I would say here, there is not sufficient evidence to support the claim that after using this drug, the mean wake time is less than 102.8 minutes. That's the proper wording of the final inclusion, or the final conclusion. And one of the reasons I'm bringing it up is this. What could we do to get more evidence?
You get to increase the sample
Well, that's one thing, right? How many people did we study?
size, 16.
Is that a big sample? That's not a big sample.
You have to be 30 to be growing sample.
You have to be 30 to know that you're going to have a normal distribution of the means. Actually, if you look at the problem, they actually said, right at the beginning, here, see how it says, Calvin, assume the 16 sample values.
Up here, okay, yeah.
So if you already know it's from a normal distribution, you can go with less. That's why they said that. But yeah, otherwise you need more than 30. So yeah, 16 is a small number. Now if you had hundreds of people, and if the mean was, 98.9, maybe that would be enough. But with only 16, this is not enough to reject the claim that, no, the mean's still the same. I think it's kind of interesting how this all works. Okay, there's one thing we did not do that the book asked me to do. We did not compute the critical value. You know why I didn't compute the critical value? They didn't give me alpha, right. So I'm wondering if I should do a critical value for this problem also. Yeah, I should. Okay? You give me a significance level. What do you want?
0.05.
Okay, let's use alpha equals 0.05 because we do that all the time, right? Now, how do you find critical values in the other section when you're using z? Well, that's where you use inverse z, right? Inverse norm, I should say. So we're good. Yeah, what's that?
Inverse T.
We're going to do inverse t. But before we start, guys, we better draw our picture. So where does that 0.05 go in my picture? Yeah, it goes in the left tail, right? Because it's a one-tailed test, so it's all right here. 0.05 is right there. And then this is your critical value. The critical value is going to be t equals, and so how are we going to do it? We're going to do inverse t of what? Well, that's easy. It's just 0.05. Some of the other problems, right, you needed to add, because it always goes from the left over. But because this is already on the left, it's kind of easy. Let's see what we get when we type in inverse t of 0.05. Calculator. Here I go. Second distribution. That didn't work. Try again. Choice 4 is inverse t. Inverse t. It says, what's the area? We want 0.05. Degrees of freedom.
15.
15 again, because it was n minus 1. 16 minus 1 is 15. That's not where I want it. Shoot. I put it in the graph for some reason. Wonder if it'll show up here. Nope. I'll get it.
Are we doing inverse T or?
We're doing inverse t. Inverse t. 0.05 and then 15 degrees of freedom. That's what I got, negative 1.75. So this is negative 1.75. Let me zoom back in so you can see again. Okay, so the t-value here is negative 1.75. So now you have to ask yourself, if that's the critical value, right? The critical value is this, right here. Negative 1.75. Do we reject or fail to reject? We still fail to reject. Why do we fail to reject? Because what was our test statistic? Do you remember what we had? I have it right up above here. It was t equals, yeah, it was negative, but it was right here, right? Negative 0.369 would be right here. Are we in the critical region or not? Not in the critical region, we're going to fail to reject. Right? So that's two different ways that you can come up with this conclusion. Fail to reject, and then you can translate it. You either, it really is an either or, but I want you to know how to do both, because there are times that it makes more sense to do the p-value, and there's times that it makes more sense to think about where's the critical region and is my test statistic in it. So you do need to know both. Okay? So you guys have any questions on this at all so far? So I want to show you one more thing that you can do, which I think is really cool. I think I showed this last time before last week's quiz. Your calculator has lots of software programmed into it already. Here, let's look at the same problem. We have all this information here on the screen, right? Let's try to do it with the calculator hypothesis test feature. So I'll show you how. The trick is knowing which one to use. So if I go to second, oh no second. We just want to hit the stat button. We're in stats class, right? We've used edit, we've used calculate, and only last week did I show you guys this huge menu of tests. Right? Guess which test I want? Number 2, you're right. Let's see what it asks for. Well, first thing it asks is, do you have data in a list, or are you going to give me the stats? I'm going to give him the stats. I don't have all the sleep times, right? Okay. I like that, stats. It's going to ask, uh-oh, I got problems here. There we go. It asked me, what's the mean? Mu. It says mu naught. It's asking you basically, what's the mean in the null hypothesis? And we're going to say what? Sure, 102.8. It's asking me for x bar. Yeah, we had that too, 98.9. It's asking me for the standard deviation. Okay. N was 16. So I don't need to give it degrees of freedom because it's going to do that automatically. Oh, and then this is kind of cool. It's asking you here, you know what it's really asking? Yeah, kind of which tailed test is this? It's actually asking you what's the alternative hypothesis, really. So we want mu less than mu naught, right? Less than that 102.8, right? Color blue? Man, I don't care about the color. Because I'm not gonna draw it. I want to calculate it. Maybe we'll try draw later and see what it does. All right. Check that out. It gave me the t-value. It gave me what else? What's the next thing? Yeah, now it says little p. It should be the big p value. Don't confuse that, right? It gave me x bar and s and n. I mean, I guess I gave that information to it. But if you had a list, it would also compute x bar at, like if you had a list of data. It could do that directly. Guys, the computer Excel Stat can do it just as easily, okay? Although my version of Excel Stat, the free version, doesn't work for Chapter 8. It does work for Chapter 9 when the formulas get more complicated, okay? So, any questions so far? Yeah, Russell?
How did you get those values? I don't know if I did wrong.
Where did all these numbers come from that I just typed in?
Well, no, I didn't get the same numbers you did, and I don't know why.
Oh, let me pause and take a peek. And in the meantime, here, number 13. Test the claim. What's the original claim? Mean weight of all green M&Ms equals, right? So okay, so they're only doing green M&Ms, right? The mean, this is number 13. The mean weight, mu, is equal to 0.8535. Right? Guys, did you write this for the original claim? This is the original claim?
Yes.
Where does that go?
Right after, no,
Yeah, that's going to be H0. So H0 is going to be mu equals 0.8535, and then H1 is going to be mu does not equal 0.8535. I feel like you guys are getting there. We're making progress. Test statistic is T. T equals X bar minus mu divided by S over the square root of N. Right? So what's that equal? I hope they gave you lots of info. Did they give this to you?
yeah, they gave us all of it.
X bar is, yeah, they gave it to me. X bar is, where to say? Oh, sample was 19, so 0.8635. That's close. Minus 0.8535. And they gave me S was 0.0570. Divided by the square root of 19. Guys, what did you get for a T value? I could save some time if I don't type it in the calculator. 0.765. Anybody else get that?
No.
Let me type it in. Let's work it in and see if we can get that 0.765. We have to be able to get it. All right. How do I get it? Did you guys use parentheses in the calculator? Remember? We have to hit this parentheses. Open parentheses. 0.8635 minus 0.8535. You guys have those open parentheses, right? And then when you do the denominator, you better put parentheses around that too, or you won't get the right answer. 0.0570 divided by, and then you have to hit the square root here, square root of 19. Move to the right and close your parentheses. Are you guys getting that? Same thing I got?
Yes.
Yeah? John, Sierra, you guys have it now? Nice. So now, picture. Let's do the critical value method, right? So the picture is this. Sarah, you had a question? No? We know the center is 0. If this is my t value, t equals 0.765, I guess the question is, I know what the critical region looks like, right? It's like this and like this because it's two-tailed. You guys, we have alpha is 0.05, is that right? So you guys split up 0.025 here and 0.025 there, right? And so next, I need the critical values here and here. Well, I guess my question is, I don't know yet if that green is really in the critical region or not. I drew it like it's not. But that's kind of cheating. I don't know that. Let's see. What's the critical region? We're going to go second distribution. What am I going to use? Inverse T of, this time it's 0.025, right? Why? Because if you look at my picture, right, I split that up. This is half of alpha and this is half of alpha. And so, degrees of freedom, we need 19 minus 1 is 18. Paste that in. Did you guys get a critical value of negative 2?
Yes.
Negative 2.1, I guess, right?
Now,
For the inverse, do you have to, does it matter if it's negative or positive, or do you just say plus or minus 2.1?
Well, yeah. See, here's the thing is we have that symmetry. So you guys, for all the problems in this chapter that we've done, the critical value here of negative 2.1, that means there's another critical value over here of positive 2.1. But I guess the point is, you could see that, right? And so you could tell, am I in the critical region with my statistic, or am I not in the critical region?
you're not.
I'm not in the critical region, right? I am somewhere in the middle. How much would this be? This would be 95%. Sarah, was that what you were asking me, is what goes in the middle?
No.
Oh, you were asking me, is there a 0 here?
Yeah.
Yes, there is. Okay. So we have that. Those are the critical values.
Oh, really quickly?
Yes?
Before we move on, with the critical values.
Yes.
Now, I remember with two-tailed test, the multiply by 2. Is that in the inverse t, or is that
Well,
in another section somewhere?
no. So a couple things about multiply by 2. I mean, I kind of did divide by 2, right?
Right.
When do you multiply by 2? You multiply by 2 when you're computing the p-value,
Okay.
right? Because when you compute the p-value, what does that look like on this problem? That looks like this. Here's the same picture. Here's the test statistic, 0.765. So it would be all this plus all that. I don't know what your p-value is, but it's going to be big. It's going to be a lot bigger than 0.05.
What's the critical region? I don't get it.
The critical region is this red area and this red area.
So because it's, okay, so it's bigger, it's not in there.
Yeah, p-value is bigger than alpha for sure. I don't have it. But anyways, if the test statistic is not in the critical region, then what does that mean? It means we fail to reject H naught. And so how do I word the final conclusion when I see fail to reject?
There's not sufficient evidence.
There is not sufficient evidence to... Now here you have to be careful. In this case, there's not sufficient evidence to...
Prove that U equals 155.
Well, but we would never be able to prove that because that was the original, right? So there's not sufficient evidence to reject the claim that the mean is 0.8535. I guess that's what I can say. Okay? And that's about it. Please work hard before tomorrow. Best thing you can do